Alrighty, let's talk area, and let's talk area of rectangular and rectangular-like shapes. So we're going to be looking at rectangles, parallelograms, trapeziums, and triangles. So everything is a rectangle. Let me prove it to you. If you've got the length and you've got the width, well, the area of a rectangle is just the length times the width. The area, just as a note, we're going to be using square millimeters, square centimeters, square meters, and square kilometers. Notice I write the square afterwards. However, we say it first. We don't say millimeters squared, we say square millimeters. Alrighty. So, area is length times width. Alrighty. Let's have a look at a parallelogram. Well, we label the B base and we label this the perpendicular height h, but this isn't a parallelogram. This is just a rectangle, right? If I move this, get rid of this bit here, that's just a rectangle. So base and height, well, that's just the same as area is equal to length times width. So B is length and h is height, which is the width, and we're done. Area equals base times height. Well, but that's just a rectangular formula. Well, it is exactly the same, except it looks different. So just for these particular ones, although the fact is that it's basically a rectangle, we give it a slightly different name. What about this next one here? Well, this one's a little bit more interesting. We have to kind of imagine for a second that we need to average it. The way we label it is we say this is A and this is B and this is H, the height. Alrighty. Well, we notice that A and B are different, but they are parallel. They are both parallel directions. We call this a trapezium. And for a trapezium, well, we can imagine, what if we made B just a little bit shorter and we made A a little bit longer? Well, if we did that, we could eventually turn it into a rectangle. Right? We could quickly turn this into a rectangle. Now, the width is obviously just going to be h, the height. But the question is, what is the length going to be? What is in between A and B? Well, let's just average it. A plus B divided by 2. Alrighty, there we go. That's our answer. So, the area of a trapezium is A plus B divided by 2 times h. Sometimes you'll see it rewritten as half A plus B h. It's exactly the same formula, it's just been rewritten. Okay? But it's half the average size, it's the average size of the two parallel sides times the distance between. There's a song for it. It goes, half's the sum of the parallel sides times the length between them. That is how you calculate the area of a trapezium. Alrighty, so that is a trapezium, which leaves us with one shape left, which is a triangle. But a triangle's not a triangle. I've never seen a triangle before in my life. Instead, a triangle is just asking to be turned into a parallelogram. And a parallelogram is just a rectangle. Everything's a rectangle. Right, so we take the height and the base, but we have to double it in order to turn it into a parallelogram, which means we want base times height over 2. You rarely see it written that way. Usually you'll see it half BH. It's exactly the same. Now, from now on, I'm going to use the formula sheet formulas just out of consistency, but just remember, these are the 4 shapes that you're most likely going to be coming up against. Triangles, parallelograms, trapeziums, and of course our favorite, rectangles. But what about curved shapes? Curved shapes exist, I know. I've heard this rumor. It's true. Now, for a curved shape, we take R, and the area of a curved shape, commonly referred to as a circle, for you people who don't like curved shape is the name, is just pi times r squared. Notice r squared is not r times 2, it is r squared. You do need to use the square button. But what about a sector? What about when I just want a section of a circle? Well, similar with what we did the other day when we were looking at the perimeter, it's the same exact game. The area is just going to be theta over 360 pi r squared. It's the amount of the circle out of the total circle times pi r squared. And just remember, these r's have to be the same. Alrighty, so that is all of our different shapes. Let's do a few practices. Alrighty, the first shape is a trapezium. We can tell because we have two sides going the same direction and their opposite sides are different lengths. So area is equal to half a plus b times h, maybe a plus b h. A is going to be 6, b is going to be 10, and h is going to be 3. That's 3 kilometers. So in this case, it's going to be a half 6 plus 10 times 3. 6 plus 10 is 16. 16 times a half is 8. 8 times 3 is 24 kilometers. And because we're doing area, it's going to be square units, so square kilometers, which is a lot. Talk about that later. Anyway, over here we have 200 degrees and 16 meters. This is a sector. R is 16, theta is 200. Substitute in, we get 200 out of 360 times pi times 16 squared, and that gives us 446.804, which we're going to round down to 80 meters squared, which is also quite a big area. Alrighty, so if you know your formulas, and most of them are on the formula sheet, you should be right to go. I'll see you in the next one. Goodbye.